don't really know what I mean by oxidation of alkene, because like this is technically oxidation, but also like this is technically oxidation. So let's just do all of them, I guess. If you were to make that prettier, hit this with Cl2 like we just did, you would get vicinal chlorines. Two things you could do here that I didn't mention last time. When we do our double elimination, what's a funny looking tube? 2 EQs of, let's just pick a base. Depending on the conditions, we can get our alkyne, which we technically oxidize the double bond to a triple bond. Or we could also get a diene, which could be used for a Diels-Alder. But that's not what we're talking about. We're okay, everybody. We're okay. Delete. If you want to oxidize the alkene into something else, such as an alcohol, you can hydrate it. I know that you know how to get an OH from an alkene, so I'm going to skip that. But you can also take this to a ketone. Had I prepared ahead of time and thought about this already, had you had a terminal alkene and a terminal hydroxy, you can use PCC to take this to an aldehyde, or you can use Jones to take this to a carboxylic acid. Had I been really prepared, I could have given you... Had I been even more prepared, I would realize the thing I was just thinking of doesn't actually work. Mechanisms, you do not need to know the PCC or Jones mechanisms as far as I'm aware. If you do, and it's on your test, I'll give you $1. First person to claim it only. The oxidation of an alkene to an alkyne through a double elimination works like so. I will draw the first step, you can draw the second step. You have a base. Arrow from the base to the acidic proton. These two electrons become a pi bond. That makes a fifth bond to this carbon. No. The two electrons in... No! The two electrons in the CCl bond pop up onto the chlorine. You get chlorine with 8 electrons. You get a Cl-. You get a double bond. You get an NH3 gas. That gives you an alkene. But hey, there's another chlorine. Hit it again. Draw it out. Oxidize your alkene to an alkyne. I think that is what I was going for when I typed out this title.